some processors. So, and the weight of this is 2 grams. The mass or the weight of this microchip is 2 grams. Yeah. So 32 MB DRAM microchip, the weight of this microchip is just 2 grams. But it is not possible if you think of 1.7 kilogram microchip. It may not be a microchip even. That is not possible. Okay. 1.7 gram, even a laptop is lesser than this. So what is this? Is there any sense? The 2 gram microchip, how comes it's 1.7 kg? That's why this is related to the inputs of raw material and energy. The microchip is 2 gram, but the raw material and energy usage for this equivalent to 1.7 kilograms. That's the point. That's the point. There are sometimes that kind of products are highly consuming raw material and resources, and semiconductor industry is one of such. Means when you are going to work in high energy and material consuming industries, you all have quite heavy challenges to reduce what? The raw materials and energy at the consumption, at the point of consumption. So there should be smart practices, operations, even the technologies you have to look into a lot. Let's say this one. This is from a journal of environmental science and technology. I got this 1.7 kilogram microchip. That is the energy and material used in the production of semiconductor devices. Semiconductor devices mean the electronic components you are seeing in your notebooks, in your cell phones, even your flat screen of your computer LED screen or in your TV screen. All are semiconductor devices. All are semiconductor devices, and those consumes enormous, huge amount of energy. So this 2 gram chip, making this chip, so they use fossil fuel equivalent to make this the fossil fuel equivalent to 1,600 grams. And chemical inputs, because they are using hundreds of chemicals when they produce this wafer fabrication, what we call in the microchips. So they are chemicals, hundreds of chemicals, but they are using 72 grams just to produce 2 grams. So the total 1,600 plus 72, 1,672 plus, yeah, so this is this much. So you can see 1,672 is almost 1,700 grams. So to produce 2 grams, they are using 1,700 grams and remaining only 2 grams. They're quite funny, but this is not to say funny, but quite, how to say, quite serious environmentally. And to produce this, they are using water, 32,000 grams, and mostly nitrogen, 700 grams per chip. Means this 2 gram microchip in your computer or in your, even now design your node in your smartphones. See, behind this there is a huge load, you know. Only with this 2 gram microchip, there carries 1.6 grams of fuel and 72 grams of chemicals and 32 kilograms of water and 0.7 kilograms of nitrogen. So total it is massive. That's why. So you can see in these industries, for each and every microchip, if you are using fresh water of 32 kg, means the 32 liters, I think water on the earth may not be enough. That's why here they recycle the water resource. Recycle. Or they, not to say recycle, they reuse it. Yeah. Recover and treat it back and reuse it again. Even nitrogen, they recover and reuse. That is what we call recycle. So that's why. So not only the raw material, yes, of course, these are raw material involved in the process, but not involved in, not consists in the product. But here they have to reuse it. They have to recycle the resources. Okay, resources associated with this semiconductor industry, making microchips and all the microelectronic devices. So this is a very nice case study to see the gravity of the resource use in making the modern gadgets and all. So the similarity, the similar cases you can see in the other industries as well. Okay. Yeah.